Okay, hello. Here goes the predicted paper for paper 3. Try to get a bit more focused. For the Maths Genie paper. So it is mathsgenie.co.uk. I always think this is a really good paper to have a go at before you do the paper 3, which is on Wednesday, isn't it? So here we go. Titles Maths. Like and subscribe and all that jazz. And here we go. We've got first question. So hopefully you've got the paper in front of you if this is a bit blurry. We've got A equals, I can't read it myself, it's at 2 cubed times 3 squared times 5, and B is 2 squared times 3 cubed times 5. Now I don't like this format of the numbers, so I'll just write it out again. So it is 2 times 2 times 2 times 3 times 5, and B is 2 times 2 times 1, 2, 3 of those, and then a 5. When I look at the highest common factor, lowest common multiples, I like to have Venn diagrams going on. So Venn diagrams, we know the highest common factor is going to be the multiple of everything inside that one, and then the lowest common multiple is a multiple of everything. So we've got A number, B number. The bit that's going to go in the middle, so we've got 2 2's here, and we've got 2 2's there, so we can put both those into there, so 2 and a 2. We've got 2 3's in this one, and we've got 2 3's in this one as well, so we can put 2 3's in here. And then we can also put a 5 in this one and a 5 in this one, so we can put a 5 in there, and then that leaves A with a 2 and B with a 3 over here. So the lowest common multiple, highest common factor, which is one we're looking for, is just this lot times together. So we've got 2 times 2 times 3 times 3 times 5. That's just a calculator job, so grab a calculator. Please make sure when you're doing the paper you are using a calculator as much as possible. So we've got 2 times, oops, no, that was odd, 2 times 2 times 3 times 3 times 5, and it turns out to be 180 as the highest common factor. The lowest common multiple will be the 180 times 2 times 3, so 6 lots of that thing, and then whatever that turns out to be. But we're interested in the lowest common multiple. Next one, we've got Verity buys 12 bottles of apple juice for a total of £15. She sells the bottles, all 12 bottles at £1.75 a bottle, so let's just work out how much she's sold the bottles for altogether. So we're going to do 12 times £1.75 equals, always good to write down the thing that you're going to type in your calculator, but then just make sure you type it in the calculator. So we're selling for £21 there. That makes a percentage profit. Well, our profit is 21, take away the 15 is £6 profit, says our profit. And then to get the percentage profit, we just put the profit over the original amount, which is £15, multiply by 100, grab your calculator, so 6 over 15 times by 100, and we're getting 40% profit down the bottom there. Okay, might have put degrees, I don't know, let's make the percent sign, so 40% profit there. Number 3, let's have a look at number 3. So we've got some standard form numbers, which I'm going to struggle to read because I haven't got my reading glasses on, so it's going to be a bit of a nightmare. Difference between the population in India, so where's India? That's that one, 1.4 times 10 to the 9, I believe it is, 1.4 times 10 to the 9. And the population of Turkey, which is this one, so we're taking away for difference, times 10 to the 7. That was just me dropping my glasses off the top of my head. Work out, give you answer in the standard form, so this is just a straightforward calculator job now. So I've got 1.4 times 10 to the power of 9, take away 8.4 times 10 to the power of, oops, and now looking at the calculator I've messed up there, haven't I? Because I haven't got out of the standard form there. There it is, take away 8.4 times 10 to the power of 7, and that gives me this number here, which is 1316, and then I've got 1, 2, 3, 4, 5, 6 zeros. 1, 2, 3, 4, 5, 6. We're on a billion, aren't we? So 1.316, and you're moving the decimal point from this point, and you're moving it back to get to the in front of that 1. 1, 2, 3, 4, 5, 6, 7, 8, 9 times 10 to the power of 9 times 10 to the power of 9. Okay. Next one, we've got this population of Iceland is 1 over k times the population of Denmark. Now we can take this 1 over k, if I multiply this side by k, I get k times Iceland, times Iceland equals Denmark, and then we've got k equals Denmark divided by Iceland. Okay, so that's just a manipulation of this thing, so get rid of this 1 over k by just times this side by k, or times both sides by k technically. and then you've got the population of Denmark, and then you just divide by Iceland and you sort it out. I don't like the blurriness of that camera, it's a bit rubbish, this camera. Is that better? A bit better. Right, so let's have a look where we're at now. So now we're on Denmark. We've got 5.8 times 10 to the 6, it looks like. So we've got 5.8 times 10 to the 6, and then we've got 3.4 times 10 to the 5. There's our two numbers, so Denmark and Iceland, and then we can just grab our calculator and figure what that one is. So we've got, let's have a look, fraction 5.8 times, oops, not that one, times 10 to the power of 6 over 3.4 times 10 to the power of 5. Okay, and I've got 17.05, so equals 17.05, which is roughly 17 to the nearest whole number, which is what it's asking for in the question. So 17 for that one. Next question we've got, let's have a look where we're at now, so I don't need that paper, I don't want that one, just looking for something else off to the side here. Number 3, just check I'm on the right track. Right, number 3, so we've got this shape here, and we're trying to work out the area of this, the shaded part, aren't we? So that's what it's going to end up with being. So what have we got? We've got a rectangle, and then we need to take away a semicircle. Well, rectangle's easy, that's just going to be a 2 and 0.75. So this one's just going to be 2 times 0.75. And just grab your calculator for that one, just to make sure. 2 times 0.75, no point taking a risk. And that's 1.5. So we've got 1.5 square meters in that one, meters squared. And then this one, the radius of this circle is half of that one. So if you're not sure what half of 0.5 is, just do it in your calculator. It's 0.25. So we've got the radius of this thing is 0.25. So the area of this bit is pi r squared. So pi times 0.25 squared. But you need to divide it by 2 because it's half a circle. So let's just do it on the calculator. So we've got, what we've got? We've got pi, shift and pi, times 0.25 squared, and then divide that by 2, and that turns out to be this 0.98 going off forever. And the idea was to take this one and take this off. So now I'm just going to do on the calculator. So 1.5 take away 0.098 and so on. So we've got 1.5 take away that last answer. So that's 1.401 going off forever. So that's how much space we've got on a door. It says Julie wants to apply 2 coats of wood to the front door, so we need 2 of them. So we need to times this by 2. So 2 times 1.401 running off forever. Here's my calculator. 2 times last answer is 2.8. So we've got 2.803 whatever meters squared to sort out. Okay. Then we told this idea, so 250 milliliters of wood varnish covers 4 meters squared of wood. Work out how many milliliters of wood varnish you will need to get to this bit. So if we start off with that question, so we've got 250 milliliters, we'll sort out 4 meters squared. Now I want to get to this number of meters squared, so what I'll do is I'll get down to 1, and I'll get to 1, so go down to 1 by just dividing by 4. And then get down to our number 2.803 by multiplying by 2.803. So I'll do that to this bit, the 250. So then I've got 250 divided by 4 multiplied by the last answer, and I get 168. Hang on, I messed up somewhere here. Where have I messed up? So 2.8. 1 square meter, and then times it by 4. Have I done that wrong? What have I done here? So I've got 250. Oh, I put 240 in the calculator, stupid man. Oh, that's going to be irritating. 250 divided by 4, and then do I ever put 240 again? I'm such an idiot. 250, that's better. Divided by 4 times by this number 2.803. I've lost the accuracy because I've had to round there, and that turns out to be 175. So we've got this one is 175.1 milliliters for that amount, and that turns out to be 175 if you round to the nearest milliliter. There I am there. Okay. Next one we've got number 5. We're going to work out What we're working out number 5, let's have a look. Number 5. So we've got this picture here with parallel lines in, and it looks like we're going to work out loads of angles here, and we're trying to get this one to the bottom, aren't we? There are lots of ways of doing these things. You've got to explain what you're doing as you go along. Now the first thing I'm going to work out is this angle here. I notice these lines making this an isosceles triangle, and what I know about isosceles triangle is the base angles are equal, so these two are going to be equal. And the other thing I know about triangles is the angles inside add up to 180. So let's just do the calculations. So we've got 180 take away our 48, so that's both of those two together. Divide that by 2 and I'm going to get 66 in each of these. Okay, so let's just write down what I've done. So EBC equals ECB equals 66 degrees. Angles in a triangle add to 180 degrees, and then the other reason that I used there was base angles in isosceles triangles are equal. So that's what it's called, the base angles in isosceles triangle, base angles being the angles at the bottom of the lines. Let's go back up to the picture. The next angle I'm going to get is this one here, and that's just these two are on a straight line, so they'll add to 180. So if I just do 180 take away 66 and 114, so this is 114. Let's have a look why. So we've got GBC there, so GBC equals 114 degrees, and that's because angles at a point on a line add to 180. And then the last thing I'm going to use is this idea of the F-shaped angle. So we go up here, across there and across there, and this angle is going to be the same as that one. So down here we've got 144. So in our spot at the bottom we've got 144 there. And then the reason, so JGH, which is what we're looking for, JGH equals 144. And I've used the corresponding angles are equals rule. So corresponding angles are equal. Now that's not the only way you can do this question, so you could do it different ways. So I could have said that once I got the 66, I basically have to use the isosceles triangles to get these two, and the angles in triangles at 180. But then I could say jump to here and get 66 down there with corresponding angles. That would be an upside down F are equal, and then I could use angles on a line, or I could come from here to here. Then I could use the co-interior angles to get to here and then do angles on a line, or I could do from here to here. Because vertically opposite angles are equal, then the Z shape gets me to here, then angles on a line gets me to there. So there's lots of different ways of getting there, but what you do need to do, you need to explain at each stage what your thinking was to get to each point. Okay. Next question. We've got this time question, distance time thing. So 56 kilometres Liverpool to Manchester, 61 kilometres Manchester to Sheffield. So you got you know the total distance. So total distance from Liverpool to Sheffield is just these two added together. So 56 plus 61. Do use your calculator. It's quite a simple sum, but just use your calculator just to make sure you know what you're doing. So that's 117 kilometres altogether. Adam's average speed from Liverpool to Manchester was 80 kilometres per hour. Adam took 85 minutes to drive from Manchester to Sheffield and work on the average speed. So for average speed you want your total distance and your total time. And what we don't know is how much time it took to get from Liverpool to Manchester. We know it's 80 miles an hour, we know it's 56 kilometres. So if you're using a speed distance time job, then we've got the speed is 80. We've got the distance is 56 and the time is what we're looking for. So we're looking for this time here, it's the t. So t is just equal to 56 divided by 80 equals, and then you can use your calculator for that bit. So 56 divided by 80, and I've got 7 over 10, so that's 0.7. So we've got 0.7 hours for that one. And then we've got to this bit here where we've got 85 minutes. Now the problem with 85 minutes is it's not in hours, and this is in hours, so our total time we want to be in hours. So 85 minutes, so you divide it by 60, so that's going to be 8, let's just do 8 divided by 60, 85 divided by 60 minutes in an hour, and that's going to give me 17 over 12. So this time for this one, so t equals 17 over 12 hours. So my total time now is this one plus this one. So total time equals 17 over 12 plus the 0.7. Let's just use our calculator. So 17 over 12 plus 0.7 is 127 over 60. So that's 127 out of 60. So there's my total time. And then I'm on to the average speed. Well, speed is distance divided by time. We know our total distance. So our speed is 117 divided by this 127 over 60 thing. And you might have done this and worked out decimal stuff. But I just leave it like that one. And I just got the calculator now. So I've got 117 divided by 127 over 60. And I get the answer, this horrible mess, which I'm now changing to 55.3 hours. So I've got, well, it's equal to 55.27 going on forever, and I'm going to say 55.3 hours, and that's where I'm going to leave that one. Make sure the decimal point's nice and clear, so even if you over exaggerate the decimal point, that's better. Ben drove from Reading to Bristol. Bev's average speed from Reading to Swindon was 80. Our average speed from Swindon to Bristol was 60. Bev says the average speed from Reading to Bristol can be found by just adding them together. So the mean, sorry, not adding together, by finding out the mean, so you add them and divide by 2. If Bev is correct, what does that tell you about the two parts of the journey? What it tells you is the time must be the same, because then you can just do that. So the time must be the same. So the Reading to Bristol time and the Swindon to Bristol time must be the same time, and then you can do this thing here. If it does the same time, then you've got to work out the different times. Number 7, a company makes boxes, large boxes. So the company has 6 machines. All the machines work at the same rate. When all the machines are working, they can make the boxes in 9 days. So what I like to think here is how long would it take one machine? And logically thinking, you should be thinking if 6 machines take 9 days, one machine doing all those boxes would take much longer, wouldn't it? In fact, one machine would take 6 times 9 equals 54 days. So that's my thinking there. And then 2 of the machines are not working, so it's important I read this bit because I nearly thought there was only 2 machines working. So that means 4 are, so you've got 4 machines working. So that's what we're picking up from that line. Work out the total number of days it's going to take. So 4 machines, if it's going to take one machine 54 days, then 4 machines will take 54 divided by 4, which equals, and use your calculator to get the 13.5. 54 divided by 4 is 13.5 days. 13.5 days. So it's important in these questions that if you've got, it's a logical question, isn't it? If a company makes large boxes, the company makes 6 machines that are going to take 9 days, then one machine must be 6 times 9. You've got to make sure you pick up that bit. Okay, next question. We've got Janet bought a new car 3 years ago. The value of the car the first year is decreased by 17%. So a decrease would be 100%. Take away the 17.5%, which equals, what's that, 82.5%. So to get this decrease, I would multiply by 0.825. At the end of the and then the value of the car decreases by 10% on this second step. So the second step is 100%, take away 10%, which equals 90%. So on that one, I'm multiplying by 0.90. I do like to have the 0 on here because I can see the 90% there. I'm then told, so this is for 2 years, and then I'm told the value at the end of the 3 years. So if I knew the value to start with, which is what I'm going to work out, I've got the new value n. If I was timesing that by 0.825 for the first year, and then I was timesing it by 0.90 squared for the 2 years, it goes down by 10%, I would end up with £16,038. That's how much I would end up with. So now it's just a case of undoing these bits. So instead of doing times, you're going to do divide. Instead of doing times, you're going to do divide over here. So the new value is 16,038 divided by the 0.90 squared, then divide by the 0.825. And that's just now just a calculator run. So let's go. We've got 16,038 divided by 0.90 squared. That's our squared, no. And then divided by 0.825. And I've got the value of the car to begin with was £24,000. This sort of makes sense because that's about the average price, I guess, for brand new cars. I wouldn't pay that much, but there we go. Not mainly because I couldn't afford to. Right. Number 9. Number 9, this power of negative a half. So the negative just means the reciprocal, so it's going to flip the thing over. So let's just deal with that bit. So you've got 9y10 over 16x4. So that's the negative part, but I've still left with a half. Now the thing about the power of a half, it's going to hit everything inside. So it's actually going to go with 9 to the power of a half, y to the 10 to the power of a half, and then over 16 to the power of a half, and then x to the 4 to the power of a half as well. So it ends up looking like this mess where the half has just jumped inside and it's hit everything. And then you're supposed to know that 9 to the power of half is just really the square root of 9, which is 3. And then for brackets, these two, you just multiply them, so half of 10 is 5. So this thing turns out to be 3y5 over, and the square root, this is the square root of 16 is 4, and then x to the 4 to the half of 4 is 2x squared. And that's all that one turns out to be. So the negative, flipped it over, and then the half, square root and everything. This type of question, I like to expand the second set and leave the first one alone. So I've got 2 minus x to kick off with. And then when I expand that one, however you're going to do it, I usually use a smiley face. So I've got 2x squared for these two. 3 times 4 is 12. Underneath you get 3x. And underneath that one you're going to get 8x. 2x times 4 is 8x. Putting these two together is 11x. So I've got 2x minus that one. And then I've got 2x squared plus 11x plus 12. So that looks like the expansion of that sub brackets. And then I'll multiply everything by 2, and then I'll multiply everything by minus x. So equals, times everything by 2, I'm going to have 4x squared plus 22x plus 24. And then underneath I'm going to multiply everything by minus x. So minus x times x squared equals minus 2x cubed, and I'm going to have to move that equal sign over here. Minus x times 11x is minus 11x squared, so minus 11x squared. And then minus x times 12 is minus 12x. I like to line the things up, and I've been a bit cramped here, haven't I? And normally it's the other way around. Normally it's an x plus 2 or something. The negative one's a bit unusual. Then you draw a line underneath and just sort them out. So we've got 24 for that one. 22 take away 12 is plus 10x for that one. 4x squared take away 11x squared is minus 7x squared. And then at the front we've got this minus 2x cubed. And there's the answer to the question. Okay. So expand the one bracket, expand the double bracket, doesn't matter which two you do. I normally just do the last two and then put the first one at the front and then just go from there. Once you've done one of them, just multiply everything inside by the first number, then multiply everything by the second bit, and then just simplify the equation down. Number 11, we've got some sort of box plot going on. Work out the interquartile range. Well, the interquartile range is just the difference between the upper and lower quarter. So the upper quarter, we need to read the scale. So the scale says it's going up in 20s, isn't it? So we're at 20, we're at 30 there, so we're on 330 for the upper quartile. And then the lower quartile is equal to, looking at that one, looks like halfway between 100 and 200, isn't it? So it's 150. And the interquartile range, the IQR, now is just 330, take away 150, which equals, you calculate out, 330 take away 150 is obviously 180, isn't it? But just double check on your calculator and you get the 180. The next one, it says draw the box plots. Let's have a look. Got smaller, lower quartile, median, upper quartile and higher, so no big deal. We've got all the numbers there. It's just a case of putting them on the diagram and then drawing the boxes. Now you should really try to get the same sort of size as this one really. So when I'm drawing it, I'll try to do that one. So I'm at 60 to kick off with. Doesn't matter where I draw it, so I'm going to go 60 from here. So maybe to that sort of size there. Looks about the right size, doesn't it? So 1, 2, 3 and 60. The lower quartile is 180, so that's here. So we just draw that line in for 180. The median's at 300, so that's here. We've got the upper quartile at 350. So 350 is probably halfway between these two, so something like that one. And then 650 for the highest number, so 650, where's that? So up here somewhere. And I'm just going to draw, oops, I've done that a bit weird now because it's a bit bigger than the others. 650, it doesn't matter, it's a bit bigger. And then I just draw boxes around these two, and then just connect those two up. And there's my box plot, a bit rubbish. Maybe should have used a pencil and ruler to draw the box plot, never mind. Says my box plot, there's another 2 marks got on this thing. And then the last bit, the box shows that the female students spent more money than the male students. I don't like that because it doesn't show that actually. It shows that on average they did. So when we look at a box plot, we compare interquartile range, so how wide the box is, and that'll tell us about the consistency. The smaller is always better, so the smaller means more consistent. And then we compare the average, so the medians here, we're going to compare those, but the phrase should say on average the girls spent more than the boys because it's slightly higher. So the girls spent more on average, but it is on average because you got this chap up here, the boys, who spent more than the girl there. All the girls, this boy spent more than all the girls, didn't he? So it's only on average for me. So when it says the box plot shows the female students spent more money than the male students, is Chris correct? It's a bit of a dodgy question. I'm going to go with on average. On average, the girls spent more than the boys. Now you can say yes or no here, and then you've got your reason. The reason's what they're really looking for when they're looking at this question. Okay, so yes or no on that one. Number 12, we're on number 12. So we've got just a conversion into a fraction. So we just write out the number. We say n equals 0.18030303 going off forever. 2 bits repeating, so I'm going to multiply by 100. So 100n equals multiplying by 100 is 18.030303. Running off forever. We write the original number underneath, line up the decimal point. 180303 going off forever, and the whole point here is when you do the takeaway now, the decimals are going to go away, so all these recurring bits are going to go away. I'm up to here where I can't now do it, so I'm doing 1803 take away 0.18. Let's just do it on a calculator, right? So we've got realising everything else has gone up to that point, and I'm just left with that question, aren't I, once everything else is gone. So 18.03, I'm going to take away 0.18, and I'm going to get 1785. So 17.85, everything else goes away, equals 99n. Next job is to get rid of this decimal. So just multiply that by 100, so you multiply this side by 100, 9900n equals 785, and then n equals 1785 over 9900. And then this is a calculator paper, isn't it? So let's not stress ourselves out. Let's just get our calculator and go 1785 over 9900, press equals, and this thing equals 119 over 660, which is what we're looking for. Okay, so that's good to go. Next one. Saffron wants to work out average number of the fish in a lake. So we don't know how many fish in the lake. This comes up over and over again, so we just call that n maybe, or whatever you want. And then on Friday, Saffron catches 210 fish from the lake. So he's caught 250 out of the number of fish in the lake, which we don't know. So far we've got 210 out of the total number of fish is how many we've caught. It now says she puts a tag on each of these fish and puts them back into the lake. On Saturday, Saffron catches 240 fish from the same lake and finds that 35 out of the 240. So we've now got 35 out of 240 have been tagged. And the way we'll make an estimate is we now need to change this 35 into the 210 by equivalent fractions. Simplest way, I guess, is just to divide this by 35 to get to 1, and then times it by, so that'll get me to 1, and then times it by 210, and I'll have 210 on the top, won't I? Okay, so that's really the target, to get these two numbers the same. There's other ways of doing it, but that's how I'm going to do it this one. So do the same with the bottom, because that's what you do with fractions. Whatever you do at the top, you do at the bottom. So divide by 35, so it gives me this 6 point whatever, 857. I don't really care about that one. It's this one that I'm really interested in. So now I times that by 210, and I've got 1440 over 210 over 1440, and what that tells me is the number in the lake must have been this thing, or as an estimation. So down the bottom, the answer is 1440 in the lake. Next one, what we've got here, we've got PQRS, points on a circle, PQ are the straight lines. Prove that PQX, where's PQX? PQX, this triangle on the top, and SRX, I can't even read. Prove that these two triangles are congruent. Well, to prove things are congruent, triangles are congruent, you're looking for all the sides to be the same. So if you can show that, you've got congruency. If you can show there's a side, an angle, and a side where the angles between the two sides are the same, then you're congruent. And then you've got ASA as well. So if I can show two angles are the same and one of the sides that's connecting the two angles is the same, then you've got congruency. The other version, this one is AAA, but the AAA just shows similar triangles, not congruent triangles. Congruent means they're exactly the same. Well, what I can see straight away is if I'm going from X to the edge of the circle, this thing here is a radius, so X to Q is a radius, X to P is a radius, X to S is a radius, and X to R is a radius. So all those lines are exactly the same, aren't they? They're all radiuses. So let's just write that down. We've got to prove it, so we're going to make statements. So X to Q is equal to X to P, which is equal to X to R, which is equal to X to S, which is equal to the radius. So that's my opening point. Next thing, so I'm on, I've got all the sides are the same so far. I can see this angle in here. So this angle in here, which I'm going to call A. So if I call that A, then this side must be A as well. Okay. So angle PXQ. So PXQ is equal to SXR. SXR. And that's because vertically opposite angles. So vertically opposite angles are equal. So we know those two angles are the same because they're just vertically opposite angles which are equal to each other. And then we've got, we've finished, aren't we? Because now we're on the SAS rule for congruency. So this side, there's an angle on this side, and that's the same as that one, this is the same, and that one. So we've got SAS, SAS, and therefore congruent. Okay, ruined. So that's where that one goes. Next question, we're on number 15. So we're looking at speed time graph. Think about the speed time graph. You've got the area underneath as the distance you travel, and the gradient, rise over the run job, is the acceleration. We're working out, work out an estimate for the distance the train travelled in the first 20 seconds, says 20 seconds, and with 4 equal strips. So we're going to draw a line up here, which hits the axis over here at, where's that, 18? I'm thinking that is 15, 16, 17, yeah, 18. I'm going to 15, which is clearly 10, so that must be 10 there. I'm going to 10, which looks like it's a 5, and I'm going to this one here, which looks like 1, 2. Looks like 2 on that one. I like to write the numbers on the top so I can just refer to them very quickly. Then when I draw these in, I've got a triangle here. I've got a triangle here. Sorry, not a triangle, it's a trapezium, isn't it? A trapezium there, and then a trapezium going to the top there. So the total area, this is just a triangle. It's a base times height, 5 times 2, divided by 2, because it's a triangle, so 5 times 2 divided by 2 is 5. This one here is a half of 2 plus 5 times 5. Let's just do it on the calculator just to be sure. So we've got 0.5 times, and in brackets, 2 plus 5 brackets times by 5, and I've got, what's that, 17.5 in this one. We can do the same in here, so it's going to be, this one is going to be a half times by 5 plus 10, so times 5 plus 10, and then times by the distance between them, which is times by another 5. So we've got 0.5 times 15 times 5, and that looks like 37.5 in there, 37.5. And then this last one here is 10 plus 18 times by 5, and then you want a half of that as well. So what's that? That's 28. Half of 28 is 14. 14 times 5 is 70, so I've got 70 in that one. And that gives me total area travelled of these three, just F4 added together. So 37.5 plus 17.5 plus the 70, and then plus the 5 as well. And I've got a total distance of 130 metres that's being travelled. Is it an underestimate or an overestimate? This one's an overestimate. Overestimate. The reason it's an overestimate is because if you look at my trapeziums, the curve is actually underneath the trapezium, so the trapeziums go over the top of the curve, don't they? And that makes it an overestimate because I'm counting this gap in the trapezium, where actually under the curve, that's not actually, that gap isn't under the curve. So overestimate, since the trapeziums trapeziums, or trapezia, I'm sorry, say trapeziums. Overestimate says the trapeziums are over the top of the curve. That will do it. And then another example, I'll know that I know what I'm talking about. Using algebra, prove that given any three consecutive even numbers, so an even number, it would be 2n, that's an even number, on three of them, so 2n plus 2, and then 2n plus 4, three consecutive even numbers. That's how we write three consecutive even numbers. The difference between the square of the largest one, that's the largest one, and the square of the smallest one, that's the smallest one. The difference is a takeaway, so now I'm going to do 2n plus 4 times 2n plus 4, take away 2n times 2n, that's a square. So let's just work that out. It's going to be 4n squared, and then I'm going to have 8n there, another 8n, so plus 16n, plus 16 from the 4 times the 4. Take away 2 times 2 is 4n squared, equals 16n plus 16. So there you go, I've worked out the difference. What's it saying? The difference between the square of the largest one, we've just done that, and the square of the smallest one, is always 8 times the middle number. So I need to do 8 times this thing. So 8 times by 2n plus 2 is equal to 8 times 2 is 16n plus, and then 8 times 2 is 16. And that's true, isn't it? Because they're the same. These are the same. Job's a good one. Okay, so the statement's true. Oh, weird. Next one, number 17, we've got straight line passes through this 2 points. The straight line is perpendicular. So perpendicular, when it says about perpendicular lines, we're talking about the gradients of the lines. So let's just have a quick look at what it looks like. So we've got 4 and minus 2, says minus 2, and there's 4, and there's our point. And then I've got 6 over here somewhere, and then 5 up here. There's my other point. So what I've got this line here, and I want a perpendicular line to that thing, and it's going to pass through this 0, 3. So perpendicular lines, we want negative reciprocals of gradients or stuff like that. So first of all, I need to know the gradient of this line. So let's just put a triangle so we can do our rise over run. This has got a rise of 7, and it runs across from 4 to 6 as 2. So minus 2 to 5 is 7, and the run across is 2. So the gradient of this thing, gradient is the rise 7 over 2, and I'll leave it like that. The perpendicular then, so the gradient of the perpendicular is equal to negative reciprocal, so it's going to be minus, because that one's positive, and then it's going to be 2 over 7, isn't it? So 2 over 7. Now I can put the equation together, so we've got the gradient of the perpendicular, so we've got y equals mx plus c is where we're going to go next, y equals mx plus c. So y equals minus 2 over 7 plus this constant which we don't know yet. What we do know is it's going to go through 0, 3. So we do know when x equals 0, y equals 3. So let's put them in. So 3, where's my x gone? Equals minus 2 times over 7 times by 0, which is obviously 0, plus c. So c must equal 3. So c must equal 3. So our equation is actually y equals minus 2 over 7x plus 3. So that's our equation of the line that we're interested in. And now what we want to know is find the coordinates of the point where m intersects the x-axis. Well, on the x-axis, y equals 0. So whenever you're on this line here, y equals 0 on this line. So this is 4, 0, this is 6, 0, y is 0 on the x-axis. So if we put 0 here, we get 0 equals minus 2 over 7x plus 3. Let's take this over. So we get 2 over 7x equals 3. Multiply by 7, 2x equals 21. And then divide by 2, x, oops, one run out of space, x equals 21 over 2, and that's 10.5 or something, isn't it? So I'll leave it as 21 over 2. 21 over 2, and we know the y coordinate was 0 because we're on the x-axis. So just leave it like that. Number 18, sorting out this mess. So what I'm going to do, I'm going to concentrate on that bit, and then I'll bring the plus 1 back in later on. So to get fractions, a takeaway fraction, you've got to get the bottom the same, so that's basically just cross multiplying the things. So you've got x bracket x minus 3, take away 2x minus 1 times x plus 3, and that's going to be over x plus 3 and x minus 3, so you times them two together. Let's just tidy this up. So we're going to have x squared minus 3x, take away. Now I'm going to be careful because I've just seen a take away there. So I'm going to expand this bracket and leave it in a bracket because I want to deal with the take away later. So it's going to be 2x squared. And then we're going to have 6 minus x is plus 5x. And then we're going to have a minus 3. And on the bottom I'm going to have, this is the difference of two squares, so that's just x squared take away 9 is the difference of two squares. Sorting this mess out, so I've got x squared take away the 2x squared is minus x squared. Minus 3x minus 5x is minus 8x. And then minus 3 is plus 3 over x squared minus 9. So that's as far as I can go with that mess. Now I've got to throw the 1 in play. So now I've got minus x squared minus 8x plus 3 over x squared minus 9 plus 1. I've got to make this over the bottom, so I'll just put x squared, so I'll go minus x squared minus 8x plus 3 plus x squared take away 9 over x squared take away 9, that's the 1, over x squared take away 9. And then the rule is for fractions, once the bottom's the same, just add or take away the top. So minus x squared plus x squared is going to go away. No more x's over here, so I've got equals minus 8x. For that one, then I've got 3 take away 9 minus 6 over x squared minus 9. So you can really see A is minus 8 and B is minus 3. So I should have some equal signs over here, shouldn't I? So that's equal to that one, that's equal to that one, then that's just new start, so that's equal to that one, that's equal to that one. Okay, so that's that one. Number, where are we at now? Nearly there. Number 11, prove algebraically that the straight line with this equation is a tangent to the circle of that one. So what I need to do is I need to sub this into that one and show there's only one answer. So first of all I'm going to rearrange this thing to y equals minus 2x minus 5, and now I'm going to take this value and put it into the equation. X squared plus the y now becomes minus 2x minus 5 squared equals 5. We can just expand that bracket. X squared plus it's going to be 4x squared, it's going to be minus 5 times minus 2 is plus 10, but there's two lots of that one, so plus 20x, and then I've got minus 5 squared is plus 5 plus 25 equals 5. Tying this bit up, you can have 5x squared plus 20x, and then we can bring this 5 over to make that plus 20 equals 0. I noticed everything being divided by 5 now, so that's x squared plus 4x plus 4 equals 0, and this thing you can factorise to x plus 2 times x plus 2 again, and that would give me that bit equals 0, so x equals minus 2. And now what this does, we can see it's only got one solution, which means the line and the circle only hit each other once. So there's only three options for lines and circles: either you miss completely, you're a tangent so you only hit once, or you go through the circle, in which case you hit twice. So they're the only options for lines. So this thing, because there's only one solution, and therefore it's a tangent. Okay, which is what we're trying to prove. Prove that algebraically that the straight line with the equation, that thing is a tangent, and that's our job sorted. Next question, last question on the booklet, says end of paper. So what we're going to do here, we're trying to work out this area here, so let's just split this down here. And we're going to do a couple of things here. So we're going to, what we're going to do to start off with, let's have a think. We're going to have a sector there for 50 and 5 and 5, and then we're going to have this random triangle that cuts it off. So if we work out the area of the sector and we work out the area of the triangle, if we take them away from each other, then we're going to get this part here, which is going to be this bit. Okay, so let's just do that bit to kick off with. So the area of a sector is pi r squared, pi times 5 squared, and then you've got 50 out of 360, so 50 out of 360 of that one times that bit. And then the area of a triangle is, the triangle is half AB sine C is the area of a triangle. So it's going to take away the triangle. A half of 5 is A, 5 is B, and sine of 50 will get me this part here. Okay, so there's my big long calculation. Let's figure out what that's going to be then. So on our calculator, we've got, let's have a look, 50 divided by 360 times by pi times by 5 squared, which is just 25, then take away, what am I taking away, so 0.5 times 25 sine 50, and that turned out to be 1.33275, whatever it's going to be. That's this bit in here. I know the second part is a bit more awkward, because on the second part we don't actually know the angle. We don't know this side's 4, so that's useful. But if we know this side, we can get this side, can't we? Because we can play on this triangle to get this line, which will then give us it for this triangle. And then once we know that side, we can get to the angle. Now, the way we're going to do that, if I concentrate on that triangle now, so there's my triangle with 50, 5 and 5. If I just use the cosine rule and call this A, then I'll get A squared equals 5 squared plus 5 squared minus 2 times 5 cos 50. So it's just the cosine rule. A squared equals B squared plus C squared minus 2BC cos A. This is a really difficult question. So A squared equals, let's see what that equals then. So we've got 25 plus 25, take away 2 times 5 cos 50. And I've now got 17.8, looks like 606 going off forever. So A must equal square root of that thing, so square root of that answer, and I've got 2.61395, whatever that's going off to be. Now if I focus on the other triangle which I'm trying to get to, so the 4 triangle, so we've got 4, 4, and now we've got this 2.61 malarkey here. We can get this angle using the cosine rule again. Now this time you have to manipulate the cosine rule to get the cos x. So cos A, not cos x, cos A turns out to be B squared plus C squared minus A squared over 2BC. That's what cos A turns out to be. So we get, what's that going to be? So if this is A, this is little a over here, so B and C are these. So we've got 4 squared plus 4 squared, take away the 2.61 malarkey squared, all over 2 times 4 times 4. So let's have a look at that one. So we've got our calculator there. So we've got 4 squared plus 4 squared, take away the answer squared, all over 2 times 4 times 4, and we get this mess here, 0.786 whatever, and then A is cos minus 1, shift cos minus 1, all of that thing. So A turned out to be 38.1426, going off forever for that one. So there's our angle. And now we're back onto this job here, so it's a bit of a complicated question, this one, where we've got this angle, so we've got 38.1426 whatever, out of the 360, times pi times 4 squared this time, and then take away half of 4 times 4, and then sine 38.14 whatever that is, will give me that other section, won't it? So this is the area of the triangle, and this is the area of the sector. So a complicated question, this one. So let's have a look. We've got ANS over 360 times pi, oops, not there though, so times pi times 16, take away, and then I've got 0.5 times 4 times 4 times 4 times the sine of that last answer, and now press go, and that turns out to be 0.3847 something or other. And then finally, so that's the area of this side here, oops, up here, so that one, and then we knew this one from that bit. If I just add them two together now, I'll have the final answer one. So I'm going to take this one and add it to this one, so I've got total answer, so I've now got 1.33275 plus the 0.3847 thing, so just do plus 1.33278. Oh, that's not right, I haven't put the decimal point in. 1.33278, and I've got 1.717 as our answer. So I've gone to two significant figures, so I've got equals 1 point, I'm down here now, 717 going off forever. I'm thinking 1.72 is the answer to that question. And that was a really tough question to finish with, but you'd expect to have a really tough question at the end. And this doesn't look like it went right, actually. 1.728. I might have to revisit that one. Oh, what a nightmare. Okay, that looks like it. If I've messed that last one up, I'll just double check that last one and see what where I've gone wrong, I guess. Let's have a look, see if I've gone wrong in fact. I've gone wrong. Have I gone wrong? That's a big question now. This video is already 50 minutes long and now I'm going to have to try to figure out where I've messed up at. Oh, that looks interesting. So it looks like that's not right. A is that mess. So let's have a look. So A should be, if I just try to jump the gun here. So it's A squared is, alright, let's try that one. So 5 squared plus 5 squared take away 2 times 5 times 5 cos 50 equals 17.86 or other. And then square root of that one. Where have I got 2 from? That's not even close, is it? Square root of ANS. It's 4.2. Where did that come from? Where did I get that? So that mess is wrong. That should be 4.226, whatever that's going to be. Oh, so irritating. So that one now isn't there. It's 4.226, so on forever. So this thing should be 4.226 going on forever. It's always useful to check things out, isn't it? And go back and recheck. Why did I mess up there? I don't even know how I did that. Anyway, let's go that one now. So you got 4 squared plus 4 squared take away the ANS. I have to square it on a ANS squared. Sorry, where isn't the squared at? Oh, I left it there, didn't I? All over 2 times 4 times 4 equals, so that's 0 point, not that one, so that's 0.441 going off forever. And then I can cos minus 1 that one, so now shift cos minus 1 of that thing. It turns out to be 63, so that's not right. That's 63.777 going off forever. And then going down here, so that will now be 63 point, I'm guessing over here now, 63, why have I put 66? 63.777, and this will also be 63.777. One mistake, it's killing me, honestly. Right, anyway, let's go for this one now. So now I'm going to the calculator, so I'm going to type in ANS over the 360 times by pi. Not there though, I did that last time. Times pi times 16, take away 0.5 times 4 times 4 times the sine of the angle that we had last time equals, so 1.72, that looks better. So that's 1.72 there actually. 1.728 wherever that goes off to. So that means that bit there should have been 1.728 whatever. So now if I just add that on now, so plus 1.33278 equals now 3.064, which is looking better, 3.064 wherever that's going off to, and that one 3.06 to 3 significant figures. And eventually got it right, he thinks. No, I messed up. Why did I get 2 there? I don't even know what I did. I'll have to watch this video back and see where I messed up there. Extra 3 minutes on the question. Honestly, if you weren't rushing Andrew, you would have been much better. Hopefully that didn't put you off too much. That last question's horrendous anyway. It's a really difficult question. You have to spot that you're getting this line in there, and then you're going to go various sectors, triangles. You have to use the cosine rule twice to get the line and get the angle. It's just a horrendous question at the end of the paper. But you're expecting a tough question at the end of the paper. And the big problem with tough questions is you make dumb mistakes as you go along. Sorry about that one. Okay, good luck on Wednesday.